Okay, we are live. Now, where did I find the chat and everything? All right, we have 5 people here so far. Oh, crap, I can hear myself. This is not fun. There we go, mute the Twitch tab. So hello to Oakville, Steffi, Steve, Stroopwaffle, and Annie. All right, if you can hear me okay, just let me know. That'd be very helpful. Because I could hear myself a second ago, so it's probably all right. What do I do while I wait for people to join? Hey, Street Waffles. Who are you, Street Waffle? Because I thought this was Annie. Do I know you? Thanks for joining. Feel free to introduce yourself. I was talking to Annie the other day about Street Waffles and how amazing they are. So I was suspicious when I saw you follow the channel. Oh, hey, Tiffany. Well, great to have you here. Good to have another fan of Street Waffles here. If people aren't familiar, there's like round, what are they? They're like those like round, flat, like kind of crunchy waffle things that have like the syrupy stuff in the middle, and you like put on, you put them on top of your coffee, so they like melt and get softened a little bit, and you eat them. They're amazing. Yeah, thanks for joining. And David has joined as well. Hey, David. Oh no, did Street Waffle leave? No. Definitely dangerous things. Maybe it just doesn't show me everyone who's here. I don't know. Oh yeah, there's way more people than it shows me in the sidebar. There's like 17, 18 people. Where's the tea sound? Just came for the tea. The tea is coming. It is just brewing, I think. I was stupid again, and I forgot to do it before the stream, so my lovely wife Yaron is helping make it now. Show us your Fortnite skills if people join. I have no Fortnite skills. I played it a little bit on the Switch and was terrible and gave up forever. I used to play Counter-Strike more. That was a bit better. So yeah, while we're like waiting for people to join and stuff, I'm gonna show off some recent. Okay, wait, here's my tea. Thanks. So, oh, it's hot. Too hot to drink right now, but I've got a South African Rubus with vanilla. It's a really nice like decaf tea if you just want to like have the fun of drinking a hot drink and tea, but don't want to get like over caffeinated. So normally I have like my morning breakfast, and then midday have like 3 or 4 Rubuses. It's like Rooibos. Uncle Iro from Uncle Iro from Adler. That's got to be one of the highest compliments I've ever received. Thank you. All right, cool. So I'm going to start off with some general OSO news, because we've had a few big announcements recently. So let me pull up my browser. So let me share my screen. One that works. So yesterday we just announced that we raised our Series A, which was pretty exciting news for us. also just like how amazing is this graphic that Steffi drew for us, a little Oso bear on his adventure. Yeah, so it's pretty awesome. We announced our Series A yesterday, led by Sequoia. So that's kind of helping us to, allowing us to continue this vision around, putting security into the hands of developers and, continue with the OSO library. So we're really excited to announce that. And there's a ton of great people who are joining us on this round as well. You can read more about it on the blog. And alongside this, we're also announcing this Authorization Academy. So you can find it in that blog post, but it's also available under Academy from the dropdown. Basically, I don't know, we've been sort of blown away by how many people have come to the OSO community, and they've been asking us around things like best practices and how do they think about authorization, authentication, authorization, how do these all fit together? And it's kind of understandable actually, because there's really not much good information out there. Typically you search for things like RBAC and you end up with these NIST documents of standards and specs and formalisms and that kind of thing. There's not much good practical guidance out there. So we're trying to address this with Authorization Academy. So on top of the introduction, we've released the first chapter, which is around sort of the structure and architecture of authorization, which means everything from how does authorization work as it maybe flows through an application, goes from the proxy to a website and so on, as well as things like how do you, what's a good sort of mental model for the authorization process, it's this enforcement piece and decision piece, and also a few different designs for how you can architect that piece. Everything stays inside the application. Maybe a central service is a common thing people try and want to do, but there's some pros and cons of that, and also some kind of new ideas we've had around some sort of hybrid of the both. So that's just some of the recent OSO news, the Series A and Authorization Academy, which we're kind of excited to announce. Since my last stream, I think there's been a ton of things really. We redid a lot of our documentation site to make it a little bit friendlier to navigate, and specifically so that it allows you to kind of focus just on your language, which language you care about, so that once you're in the Python docs, everything you see is going to be in Python. So oh yeah, cool, SQL alchemy stuff and so on. And I think on top of that, the Go has been officially released, so you can go and see the Go quick start, stuff like that. So yeah, I think those are the main developments. And then of course, the sort of releasing the data filtering functionality into the core of Polar, although it's still kind of primarily supported in the Python library right now, which is the thing we're going to be talking about today. So some tea first. So cool, yeah. So that's the main OSO news. Please, everyone who's here, I'd love it. I've got the Twitch chat up in my side window here. So anything you want to ask me along the way, any stuff you're particularly interested in, please put it there, and I'll keep an eye on it and get to it at any point. I'd also just love to hear from people what brought you here? What are you interested in learning about? What stuff can I go into? Hell yeah, we're gonna have a demo. That would be that's the first thing I'm gonna dive into as a demo of this. Yeah, let me crack on. So let's see. I think this looks good. Actually, okay, so data filtering. This new feature we just released, and the core idea behind it is that it allows you to perform authorization over a big data set, hence the data filtering, which is I want to make sure that I want to apply authorization to every row in my database. For example, they have a list of things, and I want to get all the things the user's allowed to see. That's the core use case around it. There's the language pieces that supports that, which I'm going to kind of go into in the second half of this, because I think that stuff is just fun, and it's not often we get to share people a bit of a deeper look into that. But let's start off with what's the point. So just somewhat briefly, I have a Python application using Flask and SQL Alchemy. It's sort of a GitHub clone kind of thing. So, but super basic right now. So you can see I've got some SQL Alchemy models, like a user, organization, repository. These are all extending from this like SQL Alchemy base, which basically is how SQL Alchemy allows you to define these like ORM models. So my user's got like an ID and an email. You can see them defined in the columns. Repositories belong to organizations, things like that. It's a very, very simple data model. And then the Flask part of this in this routes.py file, allows me to do things like list all the repositories in an organization. So that's kind of like the core functionality. So let's go ahead and run that again. So this is just like an API. There's no front end to it. So I'm going to access it by curling. And so you can see, let's make that a bit bigger. Is it still running? Because in my window, it seems frozen. Interesting. Just going to refresh this page, make sure I'm not frozen. Okay, cool. Yeah, it seems like it's all going all right. All right, thanks. Yeah, it's just my like preview in the screen had frozen, so I wasn't sure if it was still running or not. Okay, thanks everyone. Okay, cool. So yeah, I can curl this endpoint for all the repositories for organization 1, and I get back this like list of repositories. And so in this case, I have like a more general one, which allows me to just get all repositories the user can access, which in this case is like the same set of things. All right. And the idea is, and there are other demos of like this in more depth, other meetups we gave where we went into like all the depth of the role-based model that we're using here and the like how we're structuring an app and the data models and all that kind of stuff, which isn't really the point for today. The point I want to talk about today is this data filtering piece. So here's the implementation of that repositories index. And you can see what I'm doing is calling this also authorize model method. I'm giving it the current user, the user trying to read the SQL Alchemy session, and the model, right? So I'm saying filter for the user who wants to read repositories. And it's going to give me back an auth filter, which is representing like what repositories the user can read. You can see I'm printing it out, and then this is a SQL Alchemy filter, so I can just use the SQL Alchemy query filter to like actually get those back. So the authorization logic that we're enforcing here is like using OSO's like built-in roles model. So I have some things like say, if you have a role in an organization, you can read that organization. I have down here a rule saying that allow users to read a repository if effectively you can also read that organization. And that's for the sake of this, like we're going to go more into like policies and the syntax and stuff in a bit. But basically, I want to get you to the kind of the main point of this demo, right? I did this curl, I got back a list of repositories, and you can see here is where I'm actually outputting the like SQL queries that correspond to that policy. So the interesting thing is here, we're actually we're filling in here effectively we're just getting all repositories that belong to a specific organization ID. Have I got down the right method? Let's see. Yeah, that seems a little bit off there, but let's try it on let's try this one for organization instead. Like if we were to list all organizations, this would be orgs instead. All right, so this is really an orgs index instead. Use whatever, I don't care. Cool, so you can see I can like get all the organizations this user can access and I get back the Beatles still. Yeah, and basically what we're just seeing here is like, oh, interesting. So what I was actually expecting to see was this to be filtered by this, like some of this role policy stuff, but I think SQL Alchemy has been clever and it's automatically retrieved the organization for my user, so it's just like inline optimize this to just make it an OR over the IDs that the user kind of has access to. All right. Hey Sam, I've not seen the matches keyword before in Polar rules. Is that new? Okay, yes, that's a great question. So there's like a little, so you're talking about this piece here. So there's currently a sort of a limitation in the data filtering work where basically we can normally we determine based on these specializers, like what type something is. So this allow rule applies to repositories, and that's fine. And this works for data filtering in like the entry layer, right? So when I query what repositories can the user see, then it's like matching against this. Currently though, in this case, I wanted to do this sort of a recursive rule where I'm calling allow again, but for an organization. So in this case, this here, I'm checking, this is kind of equivalent to saying, I want to make sure the organization is of type organization. And I need to do this to kind of hint to also that when it does this allow rule, it's only matching on organizations. And I'll kind of get into this a little bit later as well, like where this is, what this is working as. All right, so that's like the quick version of like what this is achieving. And this can get substantially more complex. Actually, I kind of want to show this one because if I have it, no. I think this is what it's called. Clone rather. Nice. Oh, I'm not gonna have it all set up, am I? I can't set up now. Basically, there's an example that someone from the OSO community contributed, which is a substantially more complex version of everything I just showed, and has like a ton of really cool policies. And it's using data filtering as like the main way to do to sort of handle these. So it's got all these policies over like a ton of different models, and it's using data filtering as the way to like actually filter them down. So it's a really nice example of the constraints that you get out. But I don't have it set up because I recently had a system wipe. So unfortunately, I've lost a lot of work recently. All right. Okay, so that's like the 1,000-foot view of like data filtering, what it's for. It's spitting out these kind of like constraints or these SQL filters, so you can filter filter your data by your authorization logic. What I'm going to do now is like go right back to the beginning and the start and like talk about just what Polar is like a logic programming language, like how this differs to regular programming languages, and build back up to what the hell where these SQL filters and stuff are coming from. Okay, so take something like Python, right? Python is an imperative language, so it's just it goes through and it executes the things you tell it to, right? So I can say x equals 1, and now x is 1. I can say x equals 2, now x is 2. I can say like if x is greater than 0, print like yay or something, and so on. All right, and it's just going to like execute everything in order, right? So this is like the core like imperative paradigm. In comparison, if I take logic programming, it's less about executing things in the order that you specify, and it's more around, it's a sort of more of a declarative language where you kind of express the rules and the things you expect to be true, and you leave the sort of order of execution up to the policy engine. That's like a very, very brief, non-comprehensive description of like the difference between imperative and logic. I'm not going to go like too much into the theory. I just kind of wanted to like call out there's this like main difference. And So I'm going to drop into like the OSO REPL so we can just write some policies in line here and sort of see them execute. But like if I do the same kind of thing, right? So I could say x equals 1, and indeed, I get back as a result x equals 1. In this REPL, I'm not executing in the same way that I would in like Python. Like if I try and print out x isn't I guess I can try and print x. Like I haven't like assigned this variable. This is just like a one-off query, so it evaluates and then like everything is kind of forgotten. So if I want to chain things together, I need to AND them together. So I can say like x equals 1 and x equals 2. And you see I just get back false, right? This isn't like an imperative land where I'm redefining x. In this case, this is actually doing two different steps called unification. So it's kind of like a pattern matching process, right? It's saying, is this condition true where x is equal to 1? And well, x is previously not known. That's what we call like unbound. It's unbound variable. So like x could be 1. And we'll say, sure, x is 1 if you do that, right? X is 1. So when I say x equals 1 and x equals 2, and maybe the and makes this clear, whereas in like, above in Python land, it was less obvious. I want these things to be true simultaneously, which is, of course, false. And I can do more things, right? I can say, x equals 1 and x is greater than 0, and x is equal to y and y is less than 2. And I'm getting back my results. Like, okay, yeah, in that case, x is 1 and y is 1. That's like the solution to these things you just wrote down, right? So a lot of this querying is actually about solution finding. Now, this is kind of cool in various ways, right? So I can do like more complex expressions, like, let's just say I want to check that x is in the list of 1, 2, and 3, right? And like, what are the solutions for x is in 1, 2, 3? Well, x is 1, or x is 2, or x is 3, right? These are 3 separate solutions to this statement, and these kind of things can go and kind of go both ways. I can also I could put y in here, and I could check that y is equal to 3 or something. And like, if you think about what this means, I've said, well, x is either 1 and y is 3. That's my first solution. Or x is y and y is 3, so then they're both 3. Or x is 3 and y is 3. It's like we're computing the solution space based on what based on the thing I've tried to query for. And so like, the reason this is powerful, like coming back to say like authorization logic, and let me, not this one. I think I've got a browser window for this somewhere. All right, cool. So I've just got like a very simple polar test file. So the reason this is like really good for authorization logic is because you can start writing statements about what you expect to be true. Like, I want, a user should be allowed to read a repository. And this is only true if the user is equal to the repository owner or something. And I better have other conditions, right? I have like, allow users to do any action on any resource if like, I don't know, the user has some kind of role, and maybe the role is allowed to do the thing, right? So I can start like composing all this logic together, and I'm not responsible for telling like Polar how to go through and execute this in order to work out what's true. I'm just kind of like declaring, these are what I want to be true. Like, you work out how to solve this, right? It's this like solving piece, or this like search algorithm. It's like pretty important for like structuring authorization. So yeah, and actually this is also kind of interesting for the case of, I showed how you can get like multiple results out. So let's say, what can we do? I'm just going to start with a kind of a simple example. Let's say, a user is allowed to read. I'm not going to have these as types. I'm just going to say repository. User can read a repository if the user is Sam. And we're going to allow a user to write a repository if let's just say that's unconditionally. Actually, let's do this the other way around. You can write a repository if you're Sam, and unconditionally anyone can read a repository. So I have like two very simple rules. I'm going to save this test.polar and load this in. So I'm loading these rules in. I'm getting a warning here because I didn't use this user input here, so I could have done underscore to ignore that. All right, but I have two rules: read a repository, write a repository if you're Sam. And so kind of the cool thing is I can query these rules with various different inputs. So if I just say, I'm just going to leave these completely as variables, like actor, action, and resource, none of these things been defined previously. If I query for this, right, I'm getting back the different results that solve this expression. And you can see I'm getting one result, which is that like the actor is still just a variable. Like I haven't expressed any conditions on it. If I pull this up and have it at the side, right? So the user was no further conditions on it. Nothing happened to it. So the user is still just a variable, or the actor input, and the action was read, and the thing was repository. Or the other solution is that the actor is Sam, and in that case, Sam is allowed to write repositories. So I can get back like multiple results. The reason this is useful is because you can start asking questions like, well, I know the user is Sam. I don't know what Sam is trying to do, but I know he's trying to do it to a repository. So I want to basically ask like, what actions is Sam allowed to do to the repository, and I get back read and write. You know, whereas if I was to ask like, what can Steve do? Unfortunately, Steve can just read. So this is starting to show like some of the power of the kind of logic-based approach, as opposed to just kind of do this imperatively. Is you can start like asking it different forms of questions. But I think, you know, one of the things this may be called out is this like actor returning as a variable. Like what does that look like? What if we don't have something as simple as just read and write as like the things that return? What if it's an actor, or like maybe some, you know, constraints we spoke about before? So imagine if we had we're gonna have some other rule, which is that you can, I don't know, delete a resource. I don't know what the resource is, but I know that you need to be the resource owner. Let's see if this is going to work. So I'm going to reload that policy. And again, I'm going to do this just like allow action resource thing. And I'm getting back some crazy results here now. Look at this last one. Let's narrow down on that one. So what actor is allowed to delete what resources is kind of what I'm asking here. And you see I'm getting back these expressions where it's saying, well, I don't know what the actor is, I don't know what the resource is, but I know there's like these expressions that combine them. So for the resource, this is owner must be the actor input. And I still don't know what the actor is. And you can express the same constraint on the user input as well. Well, okay, I don't know who the actor is, but they must be the resource owner. I guess like similarly, if I could also ask like what users are allowed to delete repositories. That one I cannot do. Oh, this is the wrong way around rather. I want to ask something like maybe I want to ask what can Sam do? Sam can read repositories, Sam can write repository, and Sam can delete things where the owner is Sam, right? And so now we're sort of, you can maybe hear like based on the way I'm expressing that, right? I can access things where Sam is the owner. This is like coming back to this idea of like constraints, and maybe you can start seeing how that would tie towards data filtering, right? If I now have an expression, I can maybe convert that into like a SQL query, and that's how I can enforce these same constraints. Yeah, so this is kind of the core of this this like new data filtering functionality, is the ability to output these kind of expressions. So like previously, if I just install 10.0, is that going to work? I don't have pip. Let's see, maybe it's also 0.9. Let's just say, just all right. So previously, right, if I tried to do what I did before, what things can Sam do on natural actions? Right, you see I'm getting this like type error that you can't do resource.owner because resource.owner is current at this point a variable. Right, so if I pull back up my policy, basically, you know, Polar before is like, I don't know what you want me to do with this. You've given me a resource, you haven't told me what it is, and now you're trying to access an attribute on it and compare it to something. Like, that's not something I know what to deal with. And basically what this is kind of getting to is there is maybe this like ideal functionality of when, you know, when I'm talking about like it being declarative, logic-based, it's like solving the expression, it's, you know, it's a solving algorithm, it's like searching for results and like telling you all the solutions. The kind of limitation of like a logic language is really only just how smart is that algorithm? Like how capable is it of dealing with maybe like, you know, ambiguity or like stuff which hasn't been like fully specified. And so in this case, previously it was you could do things in a kind of declarative fashion, but there was like an ordering thing. You had to make sure that you know, if you wanted to do this, you had to, you know, first pass in, say, like a dictionary that has like an owner, right? So like, yeah, Sam is allowed to delete, you know, this dictionary because the dictionary has a field owner and the value is Sam. Like it could handle those, but it couldn't handle these like ambiguous ones where it's like, you know, unspecified. Similarly, and let's, I think if I uninstall, I think this should revert me to my local version. Nope. Don't know when it's gonna recompile. I think I've probably still got it here. So like similarly, right, to like things like lookups is, you know, what do you do with if I just say like x is greater than 0? And, you know, this is kind of much the same way where it's like maybe x is greater, you know, before it was always possible to say, you know, x is 1 and x is greater than 0 or something. Or like maybe a better one, you know, x is in the list of 1, 2, and 3, but I want x to be greater than 1. You know, the solutions are 2 and 3. But previously, it wouldn't be happy if you tried to reverse these because you'd say, you know, x is greater than 1. I'll just keep going. You know, before it would have done the same thing like we saw before. It's like, I don't know how to compare an unbound variable with an integer. And so what we did is like substantially like loosened, or, you know, we let Polar be more flexible, basically. It was like, you know what, maybe we can't deal with x greater than 0 immediately, but like let's just like hold on to that for now. Let's store it as this like expression thing, and we'll come back to that later. So you know, now if I do x in greater than 1 and x in 1, 2, 3, it has no problem with this. So let's dig into this. And I'm going to do this. I'm going to break this up instead, so that actually maybe we don't need to. So let's like see what happens. I'm going to drop into the debugger to see this going. All right, so I start out, I'm just at debug, so nothing. So I'm going to go to the next thing. Cool. The next thing is querying for x greater than 1. And you can see we've created this binding. We're saying, you know, x is, you know, represented by this expression x greater than 1. And for the debugger, we print it out to make it a bit friendlier. So I go to the next thing. X needs to be in 1, 2, 3. Okay, fine. That's the end of that one. I might need to go maybe step. Step might be the one that I need to do for this. Nope. All right, I'm gonna have to break this out. X greater than 1 and x equals 1, or x equals 2, or x equals 3. All right, into the debugger I go again. So x greater than 1. Okay, so then it hits this or condition. And you see, okay, so first I was at the combination of all of them, but you know, the first one of the or is this x equals 1. So that was like, it was pretty happy with that. Although they're not, oh wait, sorry. No, of course this one failed, right? X equals 1, but we know that X is greater than 1. So it does this process of trying to be like, okay, well, if X is equal to 1, but I have this condition that X is greater than 1, then like these things are false. They're not compatible, so I'm not going to allow that. But in the case where X is equal to 2, you see I get a result back out because that was fine. Similarly, in the case of X equals 3, that one's fine. I get back X equals 3. So it's kind of like this process there's this process where you like introduce a constraint, and then maybe you want to do this process of grounding, which is like just sending this back to a concrete value. There's a particularly challenging part of this, which is negation. So like, for example, if I say X is greater than 1 and like not X is equal to 2, well, let's see, or X equal to 2 or X equals 3. This one is a little bit harder because like, what does it mean for X to not be 1 or 2 or 3? Well, it means it's not, well, since we already know that X is greater than 1, it could be, X could be 1. I see, I'm getting confused with myself. It's so hard to work through. Actually, wait, this actually looks incorrect because we ended up with, what's happening here actually? Oh, I see. So yeah, interesting. Okay, so like I'm gonna debug this. This one's like, this shows like how hard it is to reason through these kind of things. So X is greater than 1, great. We're inside, we have a negation. Apparently that just goes all the way through. Just step instead. All right, we're inside the negation now, and we have this long expression again, X is 1 or 2 or 3. In the X equals 1 case, this would have successfully failed. This would have like successfully, what am I trying to say? Like, we kind of know that X is not 1 because X is greater than 1. So that like successfully failed. So like this being true is like okay. So in that sense, there's kind of like no further constraints to add. Like it's kind of already been covered by this case of X greater than 1. So nothing kind of gets like added up there. But what about X equals 2? Well, X could be 2 because we only know that X is greater than 1. So we kind of continue. X could be 3, so we can continue. And because I was too slow in debugging, I got this. Nice. Yeah, we should turn off that timeout for when you're in the debugger. Right, so like when we went through, right, so like X couldn't be 1, which doesn't contradict the not. X could be 2, X could be 3 based on the condition we previously had, but then the whole thing gets negated. So we're saying, well, internally inside this, we know X is not 1, but X could be 2 or 3. But then when you negate the whole thing, we're basically saying X mustn't be 2 and X mustn't be 3. So it's kind of crazy. And so like we do this De Morgan's law thing where you can turn a negation of ors into a like ands negations, yeah, negation of conjunctions and disjunctions, that kind of thing. So that's kind of where we get out. So this is like one of the really hard like implementation details to get right, was how do you do this like negation process. I wonder actually if, I'm not sure if it's clever enough to be able to like say, X is equal to 4. Sweet, yeah. So then you can even at the end like be like, okay, what about X being 4? That's fine. X being 2 is not fine. It contradicts all the other stuff we had. All right, so I'm going to kind of go a little bit into some of the changes we made in the core to make this possible. Not this one, this one. So basically, here is some of the Rust VM code. And let's find, what should we find? Maybe a compare or something. This might get a little bit too abstract. All right, so like, here we are inside some code for a comparison, right? So the comparison takes in an operator, so less than, greater than, that kind of thing, and 2 terms. So term is like the category for all of the different values you can pass around inside OSO. And so you see, for example, the scroll on my mouse is so busted, sorry. You can see, for example, that like we're doing this, like we're looking at the two numbers, and like if they're the two values, and if they're both numbers, we're just going to do like a regular comparison. And like if the comparison succeeds, then like that's fine, just kind of continues. And like that's you know how it's going to work in the regular case. If I say like x equals 1 and y is equal to 2 and x is less than y, then like this is fine, right? These are, it just compares 1 and 2 and doesn't need to do anything crazy. In fact, I can probably show you the log output for that. Y equals 2 and x less than y. Right, so like pretty straightforward, like nothing crazy going on. I'm not sure how easy this is going to be to follow, because we have this kind of abstract helper that does this. But you'll see what we kind of do is like anytime that if we have a case where one of the terms is like a variable, for example, we kind of drop into this. It's kind of like this small piece of code here, effectively. It's like, all right, well, if like the left is a, like if either left is a symbol or the right is a symbol, or in other words, a variable, then what we're going to just do is we're just basically going to add this as a constraint, right? So just put that, the things that we're going to pass around, just like shove it onto one of the variables. So if I get rid of, say, if I just say x less than 1, see, in this case, we're like querying for the same things. We're like going through the same code path of like querying, but whereas before we would have been like x less than y, we know what y is, we know what x is, so this is just like a true false result. Here we don't get any further, and we're just like, cool. Just take this whole expression, x less than 1, and just like put it onto the variable. That's kind of like that's like, in essence, it seems like incredibly simple. That's like all that you need to do is just say x less than 1, and it's like inside the VM. Where this gets really complicated is sort of everything else you need to do around that to support it. So for example, we have like an entire process of like simplification, which is where we like go through the various constraints we found and see like, can we simplify them down? So that if I have something like x equals y and y equals z and z equals foo and foo is equal to 1, then, well, actually in this case, we don't end up with any constraints. What if I say y is less than z? Like, you know, this long chain of things, like it creates a bunch of bindings and like new expressions and constraints between things. But at the end of the day, right, what does this simplify down to? X is less than 1. And this is, you know, so this is like where like a lot of the complexity in this implementation comes from, is being able to do this kind of thing. You know, we spoke about what happens if you have negations in here. So what if I say not foo equals 1? Is that going to work? Well, sort of. We're getting all the way back to, you know, for example, x is less than the variable foo, where foo is something that's not equal to 1. But it's kind of nice, right, that it's like for x in particular, it's not having to go through all this like long chain of variables and things like that. I see a question. Is the ability to generate partially evaluated expressions available in the Node API? So it's not. I believe it's not like currently. You might need to do it through Polar. I think you can get access to this manually, but we haven't. You know, we're just starting work now on like doing this for like Node RMs, for example. So I believe we have. Where do we specify it? So I think we generally, what we did was like add the ability to decide whether we would return expressions back to people or not. Where is that happening? Yeah, it seems like in the node library at least we haven't explored handling it. So there's like a bit of work for us to do in each of like the host languages to make these expressions available. I think it's partial pi. So like for example, we have you know, in Python we're converting them into these expression objects so you can kind of like interact with them, which is taking a long time to load. Cool. Yeah, so this is where you're seeing the printing is coming from, is that we're like taking that operator and the expressions and we're like doing a tiny bit of Python conversion. So we haven't yet done this piece for like the node library, but that's stuff that we're gonna be working on, like we basically started working on that today to make some of this more available. So yeah, coming very soon. All right, where was I in the? Oh yeah, I was talking through like the simplification of the expressions and stuff. So that's kind of like some of the main implementation challenges. Yeah, no worries. What else are we going to talk through? Okay, so then like the other piece is like what does this look like as it gets through finally to like the Python ORM there, for example. So basically what we've done so far in Python is we've made these as adapters for Django and SQL Alchemy, which is taking these expressions returned bipolar, right? So these kind of expressions and using them to construct those like database filters like ORM queries or adapters. And the process is actually reasonably straightforward. So you can see like this is like a big piece of it, right? It probably looks kind of nuts because it's using all like the Django dynamic query building things. But for example, equality is a kind of a simple one. If you get back an expression that says, x is equal to 1, we turn it into a query, like a Django query object, where the field is equal to the value. It's like, and like Django, for example, has this like syntax where you can kind of do operations by modifying the field name. So for example, if I got back one of these, if I go back this, right? What this lambda thing is doing, oh, I should have use black. What this lambda function is going to be doing is simply turning this into a negated query, and maybe this is maybe this is the field, whatever, like owner ID. It's like creates like a negated query where owner ID is equal to 1, right? So this would be like the Django syntax for query, filtering on owner ID equals to 1, which then gets negated. That's all this does. And like similarly for the rest of these, we could say, owner ID is greater than 1, and you get this one down here. The other piece of complexity though is like these, when you start getting into like multiple relationships and joins and things like that, right? So let me show like one of our tests. This one, yeah, this one looks like an interesting one. So for example, imagine you had this policy, right? So we're saying any user can read a post, this is like a social media post. If for every tag in the post tags, there's a tag with it, that tag has, sorry, not for everyone. There is a tag in the post tag which has the name bloop, right? So like we need this to evaluate to true at some point, basically, which means that this is, there is a solution to this. A solution means there is a tag in post.tags which has name bloop. And so we're kind of turning this into this sort of like nested expression here where, what we're looking for, we're doing an existence query for a tag with name bloop. That's kind of the core of it. But then we're looking for posts that have, that on the tag relationship. And yeah, that's kind of like the things that's getting like trickled up all the way here as you're going from like, I've got a filter on the tag, I've got a filter on the post, and I'm using that to like filter down which posts this user can read. So it's kind of like some fun stuff you have to do in here where anytime we have like expressions, like, I guess like I just showed, right? Tag in post.tags and tag.name is equal to bloop. You can see we're kind of building up this pretty complex expression where we sort of have this constraints on post. Post has this.tags contains something, a variable called tag, and also there's this expression where the tag's name is equal to bloop. It's like these are kind of stored as additional constraints, and they kind of need to be like unfolded back into a query, which is kind of cool. Yeah, there's I'm just seeing a question from earlier that I want to address from Red Dragon as well. How do you recommend bringing these policies down to the front end? So basically, I'm going to jump around a sec to cover this one. We actually have a docs guide on this. We generally recommend you try and keep your in Python. We generally recommend that you keep your authorization logic in the backend, so you're not trying to like duplicate it and copy it across multiple places. And what this normally means though is that you can return like what permissions a user has on an object, return that to the front end and do it there. So we have this example where we use this method we have called getAllowedActions. This also getAllowedActions method that returns like a list of permissions you have on an object. And again, this is using the same kind of stuff that I was showing earlier, right? Like this benefit of this like logic language is you can ask like what actions can this user do on this resource? You get back like a list. And then if you have that list of permissions, like you can pass those in an API. So in this case, we're just using like a server-side render template. It's the same kind of logic. You can, where's the, right, if, look, like do this kind of thing. Like if list roles is in actions, then display this. If delete is in the actions, then display the delete button. Like this is way, way, way simpler to manage. This like, a simple action, a simple conditional on a permission. And all the complex logic around generating what permissions the user has is done on the back end. So yeah, just that earlier question I saw. All right, so yeah, that's kind of like some of the main things I wanted to show. Yeah, kind of the final one I wanted to point out, which is like basically an extension of all this work as well. I showed how you can write, I guess I did it over here. I showed how you can do this kind of like allow actor action resource thing and potentially get back like expressions for all things. Right now, we primarily support data filtering on just like one of the inputs. So you're filtering on the resource, but there's potentially all kinds of stuff you could do with this kind of syntax where you can, instead of asking for what resource can the user see, you could maybe give it a specific resource and ask what users can see it and do the same kind of like data filtering. So instead of, yeah, I guess what would this work? Maybe this works. If I say owner, this might be too concrete. Yeah, that one's too concrete. I guess if I leave this unbound, that might work. Yeah, I guess this one's not working because this is already the constraint is only on the resource. If I have a concrete resource, it just works. But you can imagine having other rules where you're getting back like, yeah, because in this case, I guess I have owner equals Sam. I know I need to show. If I have this as user.name instead, that makes more sense. Then, suppose I did give it like a concrete resource, then I might get back, users whose name is Sam, right? And this could be like a user ID, or it could be like, that kind of thing. So you can potentially like have the constraints come back on either of the inputs. Yeah, I think that's sort of the main things I wanted to go through. I had some questions before this from one of our community members, Mike D, who has been, as I said, he was the one who built this amazing Django case management example that I was kind of talking about very briefly earlier, and has been like giving us amazing feedback on this feature all the way through. So there's a couple of things he brought up that I wanted to cover very, very briefly. One is, so this same, you know, a lot of the stuff I'm doing here, I'm doing it through the Polar REPL just to kind of show roughly what it can do. We have more work to do to basically make the interface that we currently have for data filtering like as powerful as you could do it from the REPL. So in particular, funnily enough, the question we had earlier around this get allowed actions, this doesn't currently support data filtering style approaches. But like combining the two can potentially be very interesting. So you're now asking, you're now basically combining the two questions, which is like, what are the, get me all the resources, get me all the repositories or posts, and tell me what permissions the user has on that resource, which is like this really interesting intersection between the two. And it's all like related to the same idea of like, declaratively querying the, policies. So I'm going to update my policy again, not this one. Yeah, this one down here. So imagine if I have like, I'm going to change this now to be, you can read it, whatever. You can delete if you're the owner, and you can write if, I don't know, what are we going to say? The user resource dot, I don't know, organization ID is equal to the user's organization ID. Some version of this, right? So we have two rules here. You can delete a resource if you're the owner, and you can write if you're in the same organization. So coming back to that idea of get allowed actions, right? What we're basically asking is, for a user, what action can they do to a particular resource? We're almost asking for all these things to be completely unbound. So we know that like the action is delete, then we have these conditions. We know when the action is write, then we have like this condition. So the kind of like next evaluation of this would be to like squash those two things together. So to say like, we're going to generate you a SQL query that has these filters, but then that also, maybe like annotates the result set with the permission that applies. So imagine you're basically asking like, get me all repositories this user can have, has any permission to, and for each repository, annotate it with the permission the user has for it. This is then basically like a, amped up version of this get allowed actions, where you can now start doing it over data sets as well. And this is like very much in reach. Like you can see that I'm basically getting that information back out. There's just like a little bit of work for us to do to kind of thread this information through in the right way. Yeah, so the other thing that we've kind of been spending a bunch of time on recently and kind of have more work to do is around the performance of the core. So kind of interestingly, this process that we went through of, and let's see if I can just do a Polar log for it. This process that we've gone through of like accumulating these constraints and expressions on variables, you might, based on just how much text you're seeing here, kind of maybe it's like intuitive, like, or you might expect that there is like a performance hit, and that is something we're currently seeing. So there is like a lot of like in some ways this implementation is very simple, but there's like potentially a lot of bookkeeping we need to do, especially in that simplification process, right? Like, if you look at this like expression we have at the end here, it's like, is this long like chain of unifications, resource, some temporary resource is resource, and some value is the organization ID, and so on, so on, so on. Whereas like if you're just doing that as a point in time thing, so owner is Sam, name is Sam, like far less happens. There's like way less like bindings of variables. We're just like checking some very concrete values, and it's like very quick. So there is like a performance penalty for us for like doing some of this additional like bookkeeping collection of constraints and trying to simplify them at the end. And so we've got some like more work going on here. But it's sort of, it's a very, very, very amortized performance thing, because if you can take these these filters, apply them once to like your entire data set, then that is way more scalable than trying to, for every single value in your database, applying the policy. Even if we make this policy, like nanoseconds, if you have 1 million items, it's still going to cost you, especially with the cost of fetching them from the database in the first place. Okay, so that's my little coverage of the sort of partial evaluation, data filtering, implementation, some of the challenges we're kind of facing, and just maybe hopefully like a little more insight into, you've all taken away a bit more insight into just like what the kind of like innovative or like novel language work that is happening here, because this is like some of the really fun stuff. We've gone all the way from just like one by one going through and checking like, is this thing equal, does this thing happen, to being able to like express just like what are the things I want to be true, and like not worrying about the ordering, right? Like just this ability to be able to say, x is in 1, 2, 3, whatever, x greater than 1, and x in 1, 2, 3. Like this example is super simple, but where this is really valuable is when you actually start thinking about writing policies. You don't know how this is necessarily going to pan out, right? Like I might have here, this is where like resources, resource dot amount is greater than 100, and so on, so on. And somewhere else I might have like allow something if like allow the resource, and resource dot amount is equal to 1,000. These might be combined in different ways, and like it's this ability to parse around constraints just allows you to not worry about the order of the things that are executed, which is like the sort of dream version of declarative. Is it doesn't matter what order you put things. You don't need to worry about if the type is instantiated yet or not, if the type is concrete. You don't need to worry about if you're asking for a specific resource or a collection of resources, right? So the difference between me asking, can Sam, can this user with name Sam access this resource with owner Sam, and what are the resources Sam can access? The really cool thing is when it's just the same policy logic, and the only difference is just two different parts of the code need to know how to handle those outputs. All right, so I'll hang around for a few minutes if people have any questions or stuff that they want me to go into more depth, and I'm more than happy to do that. Otherwise, I hope this has been interesting and useful. While I'm waiting for the stream to catch up and potential questions, I would highly recommend you go and check out the documentation for it. A lot of this stuff is available inside the Python language, so you can go into like the filter data guide there, and this will walk you through how to get started with this in, say, Django, and what's going on, some more examples, things like that. Yeah. No problem. Thank you, Aru. Oh, I did say I was going to come back to the matches thing as well, actually. Basically, the sort of matches is more of this constraints propagation thingy. So basically, the idea is I could say like x is greater than 0 and x matches integer, and the idea is that it's kind of being pushed on as an additional constraint. We're saying, oh, okay, like x is an integer. So if I later on, is this going to work? Right, if I later on try and say x matches a string, well, that's not true. It can't both be an integer and a string. Well, at least according to Python, it can't be both an integer and a string. So yeah, so that's kind of what that piece is about. And this same like process is what happens in a policy when I have like I could make sure this is a dictionary. I can make sure this is a dictionary. And then I guess in theory, if I do allow, so I could say resource, can I just do resource matches string? That's going to try and unify them. X equals resource, and resource matches string, and allow user action. Yeah, so for example, if my input type was a string, my resource is a string, and I see who's allowed to do what, none of these are true because I'm expecting it to be a dictionary. So instead, I could ask for it to be a dictionary. And then I'm getting back my expressions correctly. This is the kind of the main point of the matches. And the thing is, and I think this is just a current limitation of how of some of this, but if I reverse these, oops, not X. Let's see. Oh, actually, no, that works fine. Cool. So yeah, you can actually see that no, it can't be the same kind of thing is happening. I think it's where, like, if we have fields or something, that you need to apply those type checks. All right. Well, I'm not seeing any further questions, so thanks everyone for attending. Hope you enjoyed, and probably see you next month or so for the next one. Take care all.